On December 27, 2024, an automated telescope array in Chile, designed to scan the skies for potentially dangerous objects, issued an alarming alert. It had detected an asteroid about 515,000 miles from Earth, whose orbit suggested a serious chance of impact with our planet. Astronomers designated the object 2024 YR4, and early calculations were staggering. Its probability of hitting Earth was the highest ever recorded for any known asteroid. Follow-up observations helped refine its physical characteristics. The asteroid's diameter was estimated between 174 and 220 feet, roughly equal to a 15-story building. Though modest by cosmic standards, an asteroid of this size could cause devastating destruction. Researchers at the University of Western Ontario determined that an impact of this magnitude would unleash energy comparable to a powerful thermonuclear explosion, enough to obliterate a major metropolitan area. This earned YR4 a grim nickname, the City Killer Rock. 2 months later, astronomers refined the orbit once more, and the results were unexpected. The asteroid was no longer on track to hit Earth. The threat had dropped to minimal levels. However, this relief did not last long. Updated orbital calculations showed that YR4's path now intersected the Moon's orbit, and the probability of a lunar impact was even higher than the earlier risk to Earth. If YR4 struck the Moon, it would be the most powerful lunar collision in 5,000 years, potentially occurring as early as 2032. Even a Moon impact could cause serious consequences for Earth. Planetary defense teams worldwide quickly began proposing countermeasures, including a scenario straight out of science fiction, using a nuclear device to deflect or destroy the asteroid. If such a mission were approved, NASA would likely lead the operation. Images from the Atlas telescopes show YR4 as a faint moving point against the stars, while James Webb Telescope data reveal a small, bright speck, insignificant in appearance, yet potentially catastrophic in effect. The asteroid originated in the main asteroid belt between Mars and Jupiter, where millions of rocky bodies reside. At some point, YR4's orbit was altered into a stretched, elongated path, bringing it disturbingly close to Earth. Scientists believe Jupiter is responsible for this orbital shift. While often described as Earth's cosmic protector, Jupiter's immense gravity can also sling asteroids out of the main belt and hurl them toward the inner solar system, as happened with YR4. YR4 completes a full orbit around the Sun approximately every 4 years. Its first recorded close approach in 2024 brought it within 515,000 miles of Earth, about 180 times closer than the distance from Earth to the Sun. Another flyby is expected in 2028, but the encounter in 2032 is the one that deeply concerns astronomers. On February 18, 2025, scientists calculated a 3.1% chance of YR4 striking Earth. While the number appears small, it is extraordinarily high for an asteroid capable of destroying a megacity. In fact, it set an all-time record for impact probability, surpassing asteroid Apophis's peak risk of 2.7% in 2004. In planetary defense terms, even a 1% probability demands urgent attention. Fortunately, later calculations slashed the Earth impact risk to 0.004%, roughly 1 chance in 25,000. But the comfort ended there. NASA's updated models indicated a 4.3% chance the asteroid could strike the Moon, a far more serious possibility. Worse yet, scientists cannot refine this number further for at least 2 years, because the asteroid has grown too faint and distant to observe. Until its return in 2028, YR4 is effectively lost in space. Experts from the University of Hawaii caution that the 4.3% lunar impact probability is not exaggerated. If anything, it may rise. YR4 has never passed this close to the Moon before. Even minor gravitational nudges from the Sun or another body could alter its path significantly. A tiny orbital shift could increase the lunar impact probability to 100%, or redirect the asteroid back toward Earth. Given that Earth and Moon are only 239,000 miles apart, even slight perturbations could produce catastrophic consequences. Many assume a Moon impact would be harmless to Earth, but the opposite may be true. Most planetary defense scientists warn of potentially severe fallout, including dangerous debris, spacecraft damage, and disruptions to space travel. A later section explores this scenario more deeply. For now, consider the darker possibility: YR4 changing trajectory and heading straight for Earth. Asteroids smaller than a few feet burn up in the atmosphere. But there is a known threshold, the 115-foot rule. Any object larger than this will not completely disintegrate. With its estimated size of 174 to 220 feet, YR4 would reach the ground intact. Although far smaller than the 6-mile-wide asteroid that caused the dinosaurs' extinction 66 million years ago, YR4 could still inflict enormous damage. Based on earlier analysis by asteroid hunter David Rankin, the initial potential impact zone stretched from South America across the Atlantic to sub-Saharan Africa. However, risk corridors can shift dramatically as calculations improve. If YR4 entered Earth's atmosphere at its current speed of 38,000 miles per hour, about 10.5 miles per second, and at a steep angle, it would reach the surface in under 10 seconds. A direct impact would unleash devastation comparable to the 1908 Tunguska event in Siberia, where a similarly sized asteroid exploded in the atmosphere, flattening 80 million trees over 830 square miles and producing shockwaves recorded worldwide. If YR4 were metallic rather than rocky, it would be far more destructive than Tunguska. It would likely reach the ground intact. If it struck a major city like New York, the resulting crater would be roughly 1 mile wide, with total annihilation extending 2 miles from impact. Shockwaves could demolish buildings within 5 to 6 miles, ignite massive fires up to 10 miles away, and cause destruction surpassing the Hiroshima and Nagasaki nuclear blasts, minus the radiation. While such a scenario is terrifying, the current data indicate the Earth impact risk is extremely low. The Moon impact risk, however, remains at 4.3%, the highest ever recorded for a celestial collision. If YR4 strikes the Moon in 2032, the impact would be immense. Without an atmosphere to slow it down, the asteroid would hit the lunar surface at full speed. Calculations by astronomer Paul Wiegert predict an energy release of 6 million tons of TNT, about 400 times the Hiroshima bomb. The impact would carve a 1 mile wide crater and eject vast quantities of lunar rock into space, some visible from Earth as bright plumes if the collision occurs on the Moon's sunlit side. Most of the ejected debris would fall back to the lunar surface. but around 0.2%, equivalent to 20 to 200 million pounds of material, would head toward Earth. This would create a spectacular meteor storm, thousands of times stronger than typical meteor showers. The debris would burn up in the atmosphere, posing no threat to people on the ground. However, astronauts in space would face extreme danger. Even small fragments traveling at 22,400 miles per hour, 6.2 miles per second, faster than most bullets, could puncture spacecraft hulls or spacesuits. Satellites could suffer damage that might trigger cascade collisions known as the Kessler syndrome, potentially jeopardizing long-term space operations. Though unlikely, scientists do not dismiss this scenario entirely. To mitigate risk, some teams have proposed a dramatic solution: a nuclear deflection mission. The idea is to launch a spacecraft carrying a nuclear warhead to YR4 and detonate it above the asteroid's surface, fragmenting it into smaller pieces that would burn up in Earth's atmosphere. Such a mission would need to be launched between late 2029 and late 2031, when YR4's orbit brings it close enough for interception. But hitting a distant, fast-moving target is extraordinarily difficult, and even small errors could doom the mission. Waiting until the asteroid is nearer, such as by the Moon, would increase accuracy, but leave no margin for a second attempt if the first failed. When YR4 returns in 2028, astronomers will finally be able to refine its trajectory again and determine whether the 2032 lunar impact probability rises or falls. For now, the 4.3% risk remains the best estimate, high enough to concern experts, but not high enough to justify panic. And humanity still lacks any guaranteed method to stop a major asteroid impact.